And I'm actually running this off my phone right now.
Nice. I found a cool app. It's I'll send it to you. It's Cam something, but you can use your iPhone or whatever as a webcam wirelessly through your computer, so you get a better quality. If you don't have a good webcam, it's a good solution for a better quality camera.
Yeah, well, I hate Apple, so.
You said you hate Apple?
Yeah.
Yeah, I do too. The only reason I really use it is because my kids love Apple, and I like us all being on the same calendar, so I can, manage things better.
No, because the RTC works well with the Apple, and the P series works well with Android.
Yeah.
For some
Although
reason.
I'm finding my uses for the P series dwindling by the day.
Mm-hmm.
As it,
Hey, don't knock my P50.
No, I'm not.
It's my baby.
Yeah, I'm not
it's
knocking
a monster to carry.
I just find myself more in need of being able to move quickly than shoot further. But that's not everybody, right?
No, I agree. It's the same thing. I mean, we switched so much of our work over to the RTC. But there are those cases when you need the range with it and so on, and it is better data quality, but the RTC gives it a pretty good run for its money.
Yeah, it's questionable anymore, I think.
Yeah.
About the data quality. I mean, I think the only time I really tell a big difference, or not a big difference, but a difference between the quality is when I go to mesh, right?
Mm-hmm.
Other than that,
pretty subtle. It's pretty slight.
Yeah.
So.
And I just realized why I couldn't change what I wanted to change. I wasn't looking at the right screen. Oh, we're 3 minutes in. We could probably start. I think we're missing a few people, but we are also streaming to YouTube and LinkedIn. So, I mean, just that's for your guys' knowledge. If
Especially Ben.
If there's any opinions that you don't want to be out there, it is no longer time to share those. And if in the future we don't want to stream, that's fine. But I'm also trying to include other communities to try and get more people in. So if you guys don't know Mike and Ezra, they are two of the smartest geomatics people I know. PhDs. And I'll let them introduce themselves, but if you guys want to take it, they're here to tell us about some software they're developing. You guys have the ability to control?
Yeah. So we'll set this record straight, give a kind of a quick introduction. So the smart person's Ezra there, but I'm Mike Olson. I'm a professor at Oregon State University in our geomatics area. Been working with LiDAR data for a long time in different applications like sea cliff erosion, asset management, feature extraction. And in our research group, we've done a lot of basically kind of algorithm development. And a few years ago, we started a tech transfer company to try to give more life to the research products we're producing, because most research grants are 1 to 2 years. We develop these tools, but then the research isn't really a way to sustain the tools that we develop. And so we're looking at different avenues of getting these products out there to commercialize things and make it easier to process LiDAR data. Ezra, do you want to do a quick intro?
Sure. Hey, everyone. I'm Ezra Cha, and don't really agree with Mike about me being the smarter one because he hired me. So I think they just make him smarter. So I did my grad school at OSU and continue as a postdoc in the research faculty. And I've been doing LiDAR data processing, doing a lot of algorithm development, about like over 10 years at this point. And definitely kind of did a lot of work in this room and to improve the workability of LiDAR data to kind of really help more people kind of go through the barrier of using or dealing with those large volume data sets. All right, Mike, back to you.
Yep, thanks, Ezra. So it jumped a lot faster than Zoom to share there. So sorry, I kind of popped that up here. So Thank you, Mac, for setting this up and giving us the opportunity to be here presented. Thank you, everyone, for being here. This can be pretty informal. We're going to kind of mostly just talk about today, kind of a high-level sampler of some of the different tools and products and things that we've been developing, and can kind of take it the direction that you all want to go with it. So feel free to pause us with questions and other things as they come up. So just to kind of give you a quick overview of our company, we're basically a startup out of the Geomatics Research Group at Oregon State University, and have a lot of these different tools that we've been developing for point cloud segmentation, classification, asset management, road marking, and rockfall analysis are kind of some examples of some of those. And so we'll talk about some of those today that are of most interest. And then the other part that we do in our company is look at different custom software workflows or data analysis solutions for working with point cloud data and fitting those in. So we've got several of us as part of the company. Myself, Ezra, my wife Kristen is our financial officer, and Benny Beaver, since we're a spin out of Oregon State University, they are a part owner in the company. So kind of our philosophy and the way kind of our different products fit in is we look at kind of the full spectrum of point cloud data out to the products, and have a number of different tools and techniques we've developed kind of fitting it at each stage of the workflow. So your initial data management, we've got a toolkit called EasyPC for doing a lot of file conversion, as well as extracting information from files and getting files from one package to another. Then we've got other tools for filtering like EasyVox, Point Cloud Registration, PointReg, and then tools that get into the processing and analysis in terms of ground filtering, segmentation, feature extraction, and the Rockslope stuff. And so, ultimately those tools then kind of spit out different data products that can be used in GIS or other types of software. And one of the things we've really focused on in terms of both our research at Oregon State and then our activities through EasyData MD is putting more of the intelligence in the point cloud. As you guys well know, working in this, we spend a lot of time doing line work or extracting things from the point cloud and throwing away so much information in the point cloud. And so a lot of what we focused on is how to get this information encoded in the point cloud, so you have that intelligence built into the point cloud. And I think we're starting to see that happen more and more in the industry now, where that's becoming the focus, and getting people more comfortable working with the point cloud and saying, we don't need to do all this extra line work. Yes, there are applications, there are things that's necessary for, but the more we can deliver the information in the point cloud and have that serve as the main deliverable, the better. So we have products that kind of help with both of those different directions. So with that, I'm going to pass it on to you, Ezra, to talk about basically the feature extraction tools. So we decided we'd kind of switch off to keep it a little more exciting than listening to each one of us blab on too much. So Ezra, pass it on to you.
All right, just give me 1 second. I think Team just hijacked my screen. And
well, while you're working on getting that up, am I wrong to assume that since OSU is technically part owner, they benefit somehow from the software?
We're not allowed to discuss the terms of that agreement.
Oh, okay.
We signed a lot of paperwork. I mean, we can't say any specific details. We can't give like the number and so on. But yes, there's an equity stake they have in our company.
Well, I mean, that's a value add. I mean, I would rather my money go to you than some stock, or OSU than some stockholder somewhere, right? So that was my question.
And that's the intent with it is, we pay royalties to Oregon State University, and then those royalties trickle back to help fund our lab and other things with that. So kind of feeds into the research. Any luck, Ezra? Or do you need me to drive?
I think I'll need you to drive for me for now.
Yeah, if you're on a single screen, Teams is a bit hard to navigate. It's already kind of tricky with the two here. We use Zoom and Google a lot, so Teams is kind of out of our element. All right.
Okay.
So you're ready, feature extraction?
Oh wait, I think I just make it work. All right.
Okay.
Let me do this. Sorry. So team basically disabled one of my screens, and I have 3 screens, and I think I'm showing my screen now, right?
Yep, you're good.
All right. So the first thing I'm going to show here is just going to go to show like some of the tools that with the more visual. The first thing is the row feature extraction. So in here, in this package, we call it the easy fit, the easy feature extraction. We have the curb and ramp detection functions. We have the programs for road and path extraction, and we also have a basic version of the marking extraction. And here's just a quick example showing the performance of some of the feature extraction. As you can see here in the point cloud, this is a mobile LiDAR data. This is collected from the Pixis, Leica Pixis 2. And you can see the red points. They are the curb classified in the point cloud, while the green points are the ground surface. So in this case, it's pretty much the sidewalk. And the intensity map, the grayscale, the points in grayscale, they are the road surface extracted. And it's worth noting those driveways are classified into the road as they are the path can be driven by the vehicle in those cases. And so here is another example showing the curb extraction. So as Mike mentioned, so everyone spend a lot of time in generating those line work, but those line work cannot be converted back or projected back to the point cloud necessarily. And in this case, so our philosophy is to make the LiDAR data very easy to use and also make it reusable. So in this case, you can see the classified point cloud data with the curb extraction results, and you can extract the curb class from the point cloud and use those to guide the production of line work, for example. And it kind of does like 90%, 80%, 90% of the work already, and from there, picking up from there, and the following work will be much easier. And benefit of this, again, is all this information are stored in the point cloud data. So you can carry this point cloud to another step, to another processing applications, and take and leverage the processing that they've already done to it. And then here is the road detection. So the road detection can benefit from the curb extraction results, as mentioned earlier, and it doesn't have to go on top of the curb extraction. So it utilizes a number of advanced algorithms that were developed over the years. One is called the Nirvana. It's a normal variation analysis. It's a point cloud segmentation approach. A lot of our tools are running this Nirvana engine in the back, just to cluster the point cloud, simplify the point cloud, extracting features, and then we apply more filtering and semantic classification to complete the feature extraction process. In this case, have a complete results for classification, as you can see here. Once we have the road surface, we can further classify the markings within the road classes. So in this case, you can see the green points represent the road surface, the blue are the curb, and the yellow are the markings. So and the orange here is just the other ground points. So those gray points are the on-ground point cloud. So another thing you can do here is we have the Nirvana segmentation tool that can segment the point cloud into objects. So if we divide this point cloud into ground and non-ground points, in the ground points, we got all of these different features. And for the non-ground points or the objects, we can classify those or segment those into different objects and to further classify on an individual object basis, rather than every individual point basis, which can significantly reduce the the computational complexity and the speed up your workflow. And I think the next one, Mike, I'll pass it. I'll probably go through the Volsmog, the ground filter first. So a lot of the approaches or the tools that I showed rely on a good ground filtering results. And we in our house we have several ground filtering algorithm ready to tackle different types of data, different types of scenario for different applications. So Volsmog is a award-winning ground filtering algorithm published in 2021. It won the Best Paper Award for 3D GeoInfo, so really well received and recognized internationally. And so the basic function in this, so there's like two modules. One is a classification. It takes the input point cloud data in LAS, LAZ format, and it can be from any source, any platform, and it can separate the ground and non-ground points, assign the classes to those points, and it can support multiple iterations. So which means you can do the ground filtering gradually. So you can do a very coarse ground filter, and then on top of that, you keep refining the results. This all happened automatically internally, and you have control over it. Just kind of determine how fine you want to go into this. And because a lot of times for the complex ground or very challenging terrain, you need to kind of have multiple iterations to pick up more and more grounds in every iteration. Again, it's very versatile for different ground types, and also there's sources. So in here, I'm just showing the mobile LiDAR data again in a urban or suburb scene, and we also tested on natural terrain, on steep slope, and all right. So I'm going to have some examples showing later. And it also has some modeling capacity to generate a DEM or TIM model, and it supports the whole filling. So here's the example. So there are some data gaps in the data sets in this mobile LiDAR data caused by occlusion from those moving vehicles. And in the results, we can generate TIN or DEM or grid points with those data gaps interpolated. And here's just a more example showing the versatility of the Volsmog ground filtering. So here is the UAS LiDAR data in a coastal area with a lot of slope and the coastal cliff. And here's the UAS structure for motion data. There's a lot of data gaps in this because the structure for motion data, the drone imaging doesn't penetrate the tree canopies and so on. And all of those, both of those are heavily vegetated. So it can overall has a really good performance. Treasure LiDAR, so in this case, this is on campus, on OSU campus, with a mix of the buildings, road, sidewalks, and along with a kind of a very smooth terrain there, and also airborne LiDAR. So in this case, there's a kind of good mix of a lot of things in this scene, and overall it performs really well. Okay, so now I think I'm gonna pass it to Mike. Oops, now it just crossed this. All right, I'm gonna stop sharing. Mike, you're muted.
Yeah, thanks Ezra for the tour there. And before I jump into the road marking extraction algorithm, which was the next one we were going to go over, I figured maybe we'll take a pause and see if there are questions for Ezra on the road feature extraction, ground filtering, or any burning questions anybody has.
I have one quick. So can you leverage, for instance, existing classifications? So if you bring in a pre-classified file, can you kind of use those as a starting point to then enhance it further, or is it better with your algorithms to kind of start from a blank slate and kind of build up using your own extractions?
So the tools, every tool that I just mentioned, they can all run by themselves, which means you can kind of bring in a pre-classified point cloud and then kind of build on top of that. For example, if you don't want to use full smog for ground filtering, if you want to use a different one, or it's already classified, that's totally fine for all the rest of the tools. For road detection, you can bring in, like the curb points or curb other classified point cloud in there, and then just to extract the road surface. So those are all built in. So internally, it's just a kind of recognize different class ID. So there's a lot of flexibility there. So sometimes we would mix and match different tools within our disposal as well. So great question.
You mentioned drone data, you mentioned Pegasus data, and those are two of the new Pegasus isn't bad, but the two of the noisier data that you could deal with. Is there any certain type of data that your software doesn't work well with, or?
So, well, yes and no. So there's always challenge with the data. So one thing I can think of, if the data, so let's take a mobile LiDAR data as an example. So normally it will work really, really well. But when the mobile LiDAR is driven at a very slow speed, and also it's turning, like a very sharp turn, very slow and sharp turn, and you will end up with a much higher relative errors, like locally, because your scan line starts stacking up to each other, and also the IMUs start drifting and everything going in, and it causes a lot of ambiguity in the data set itself. And similar case is when you have, for example, terrestrial LiDAR, it's not processed properly, and you have some misalignment in the registration error, and then suddenly you have like two ground surfaces, for example, right? Like one on top, one at the bottom, and then sometimes it can confuse the algorithm, like which one to pick. So those are the some of the challenges there. And for other data sets, so we tested, like from like $100 solid state LiDAR to, like $1 million airborne LiDAR system, like at different range, iPhone LiDAR, pocket LiDAR. So we tested those as well. So it just worked really, really well for all of those. Only when, there are artifacts in the data itself, sometimes it hits, sometimes it doesn't. Yeah.
It looks like there's maybe a 6 to 10 minute delay on LinkedIn, and we have about 6 people watching. So if the questions come in, I'll ask them later, but feel free to move on if you want to.
All right. Sounds good. All right, so I'll go ahead and talk about road marking extraction. So this is another tool that we've been developing. This was part of a research project we did for Oregon DOT, looking at the capabilities of LiDAR to perform retroreflectivity assessments. And so one of our colleagues, Jae-Hoon Jung, who was a research assistant professor at Oregon State and also part of our company, was kind of the lead developer behind this. He currently is in collaboration with us, but he took a new position in Korea back in his home country. And so part of that, he wasn't able to kind of continue as a full member of the company, but is working as a consultant in order to help us maintain this. So with this research project with Oregon DOT, we had developed a software tool called ROAM, the road marking extractor. And this tool is something that we handed on to Oregon Department of Transportation. They've now built custom GIS tools on top of it and have been running it with a wide range of data sets. And for those of you that aren't familiar with Oregon DOT, they owned a Leica Pegasus system. They just purchased a Regal one that they're in the process of onboarding and have taken out for a few collects now. But they drive their state at least every other year. So they drive half the state one year and then the other half of the state the next year. And so they've been collecting a lot of LiDAR data and have been using this tool for a lot of different road marking projects. And so we just found out this year that the project we did with them was taken for an AASHTO High Value Research Award, where ODOT basically found the cost of the research project alone was saved with one project that they used this tool for estimating pavement striping costs and so on. So kind of cool to see that implementation and where they're taking it. So anyway, so we have a GUI that helps people set kind of the basic parameters, the cell size of the analysis, which again is a function of the resolution of your data, the road width, how large of intervals you want to do. This is just a way to make the processing more efficient by working on, a size of interval, say 500 meters at a time. So you're not trying to work with too long of a stretch, and some basic parameters with that. And then from there, there's options to export different types of tools, export the road markings. It's capable of exporting basically CSV files that have all this information encoded in it. And then we have tools that basically input those into geodatabases into ArcGIS software. So the tool that we have has the ability to extract the markings. There's a classification tool as well with it to classify the different types of markings in the point cloud data to work with it. And so I'll show kind of just a few examples of some different data sets with it. So here's an example of a data set on a slower road near Philomath, Oregon. And basically the tool operates at about 0.2 to 0.3 million points per second. It varies kind of depending on the type of data set, but it's a pretty efficient algorithm for processing the data. And so the green points you see here are the road markings extracted from that section. Here's just kind of another one with more complex markings at an intersection. And one thing that I think we want to kind of emphasize with this is we really focused on the tool being able to extract worn markings and surface markings. On the research side of things, there's a lot of research in pavement marking extraction, but most of them are just extracting markings from the really well-defined, recently placed markings. And so we worked a lot with Oregon DOT to kind of find sites and locations where the markings were worn and really kind of clean up the false positives that come in, because the intensity signal really degrades where you have those worn markings. Here's just kind of an example of another data set with the markings extracted. So picking up the different sections, there's a few spots we're not quite picking up in these locations, but overall the bulk of the marking and those sections are being picked up. You may wonder why this marking on the left side of the road isn't done there, and that's just because we have a range threshold to try to kind of help. And in this case, the range cutoff was just past the skip line there. So if we wanted to extract that marking on the opposite side of the road from where the mobile LiDAR was, we can just include that extra range there. And so the other thing we've been doing with the tool is, initially we developed this tool with, the Leica Pegasus data that the ODOT have, but you always want to kind of test out on different sensors. And so we've tested out the tool with some of the Regal sensors for road marking extractions. And I know there's some folks in Australia that were working with that as well. We also had some folks that were interested in using it with Velodyne data, which is one of the most challenging data sets to work with, because you've got 64 lasers, in some cases on it. There's kind of noisier data. There's not really good calibration in the intensity between those different lasers, and so it gets a little bit challenging to work with it. But we developed some approaches to kind of clean up the data and pick it up. And so here's some examples of some lane markings extracted from the Velodyne data, and especially with kind of the skip lines going through the intersection. You can see there's a lot of complex markings and things that it picked up pretty well in those areas there. So we're always kind of keen to try it out on different areas. And then, in this we're using, in a lot of these tools, a mix of, in some cases we're applying some machine learning to it. Other cases we're applying basically a rules-based approach. We tend to try to do as much as possible using rules-based approach because it's very versatile and can be applied in a lot of areas. One of the big challenges, and you see in a lot of the point cloud classification tools that are out there today, is they rely on machine learning. And so they work great if everything's the same as what you trained it on, right? But the training process is very cumbersome, and a lot of times there's unique things in each data set that cause it to fail and not classify things correctly. And so you got to spend all the time retraining, and things become very complicated. So we try to build in as many of those rules as possible, and then we use machine learning where it makes sense to put it in place, and do a lot to augment the training data set so it handles a lot of different data types and so on with it. So it's kind of a mixed approach between it. So the straight lines, the linear lines, the broken dotted standard parallel, those are all kind of based off of different geometric and intensity rules. And then for the complex markings, we're using what's called the modified visual geometry group net. And we have basically 33 trained data sets that we put into it. So quite a lot of digitization and marking in order to make that happen. because you got to basically go through and isolate those manually in order to build up that training data set with it. The other aspect with the road marking tool is we, in conjunction with the study for Oregon DOT, we did a radiometric calibration of their system so that their measurements that they were getting with the mobile LiDAR data and intensity could be scaled in order to match a retroreflectivity from a handheld retroreflectometer. And then using that correlation with the system, we can then take the extracted lane markings and look at the intensity values of the points and then basically simulate a handheld retroreflectometer. And so in this case, it's simulating a handheld retroreflectometer going every meter along the different stripes. And that's what the different colors are and represent the different retro values, with green being 350. And so that function and capabilities in the tool. Now, the caveat to that is in order for it to be applied to a different mobile LiDAR system, you have to perform the radiometric calibration, because this correlation is just for Oregon DOT system. But we've connected with some folks in Massachusetts that are doing radiometric calibration there, and the curves follow the same function with the Regal system compared to this, and so it's really kind of establishing those different parameters and putting them in place there. But then once you get that, then you can take it into a GIS database. We have a tool that aggregates to basically give a condition score along the highway. So it takes all the markings that it sees in an area and then starts looking at what those general ratings are for the markings, and then making a decision of which sections are the ones that are going to need the painting the soonest. And so they can kind of look at this at a network level across the state to decide which are the areas they're going to focus in the next round of maintenance with it. All right, so I'll switch it back to Ezra to kind of talk about the next product here, EasyPC and EasyVox, but pause here for some questions, give you a break. Again, today we're kind of doing a sampler, but happy to go in more details where people would want to do that.
This may be the wrong time for this question, but if you were to purchase this software, is each one of these options modular, or is it all-inclusive software?
Great question. So basically we've set it up so that these are modular tools. So we have like different bundle discounts and so on when you purchase the different tools together, but they're all kind of their own separate packages, so you can script them or customize them in the ways that you want to. So there's some tools that have kind of end-to-end, when we talk about the rockfall analysis tool, that's one that's kind of set up that way. But the other tools are so they're built on each other. You can do a lot of batch processing with them for efficiency, and then carry them out and visualize the results.
Part of the reason, and I hope you guys, I don't speak out of turn here, but part of the reason I invited these guys to come to speak to us is because right now they are kind of custom putting packages together for bigger clients. And I thought maybe this group would help kind of steer them towards a mass produced product. And I don't know if they haven't expressed that's exactly where they want to go, but it never hurts to know what the market wants.
Yeah. No, definitely. Thanks, Matt. Yeah, that's something we definitely love to kind of hear the feedback of what would make sense. And that's one thing we can do in our custom development is if you say, hey, this is what I want to do. I want a tool that just runs all these in, batch together. Then that's something we can put together with it. We've tried to design it so it's.
I can tell you, for me, all right. One of the first things you said was that this works with lots of different sensors. So that's great because I don't want to be beholden to one brand.
Yeah.
So that's a great option that it works with several different LiDAR sensors. So.
Yeah, definitely. That's something that's been important to us is test these out with it. Obviously there's a suite of stuff and stuff that we haven't tested. So if there's things you want us to test, say, how well does your tool work with this? We can do some runs and kind of show you what the outputs look like. But we've tried to design a lot of these tools so they aren't, competing with like the big dog software, but they feed into the different softwares, right? So they can come at kind of some steps in between. Since, in a lot of LiDAR processing, it's rarely one package that does it all that you want, right? You're usually going between a couple. And so these are tools to do a lot of that batch processing efficiently to get it into your package for the next step of what you want to do.
And I don't know if you guys kind of noticed, they showed the UI there a minute ago. And to me, it kind of looks like video converter UI, where you kind of throw data in and the data you want comes out the other end, but there's not a whole lot of like confusing steps in between.
Yeah, exactly. A lot of it's set up for batch processing, right? We have lots of data sets we need to clunk through, and we want to put it through. Yes, there's always going to be things that you're going to want to adjust and do at the end. So we usually, especially if we're working the new data set, kind of make sure our parameters are set the way that we want. But we do a lot of testing through the research to make sure that the parameters are very versatile and you're not having to turn 30 knobs to get the result out the way you want, right? Because nobody wants to do that. And so we try to pick intuitive parameters when they're there. So it has a meaning, like what's the resolution of the data set, is a common one.
All right.
All right. Yeah.
I think that's a great segue to the introduction of EasyPC, because we kind of touched a lot of things that is directly kind of going into EasyPC. So EasyPC is an efficient data management tool or toolbox that we developed. It's very powerful. It's doing a lot of basic things. So here, just kind of highlight a few points that I want to make here. I believe everyone agree handling those large 3D LiDAR or point cloud data is very challenging. It's very hard, especially when you have very large volume data and it hits hundreds of millions of points or billions of points. And the batch processing will be crucial to handle all of this, because even just to handle like individual files will be painful, right? Will be very time consuming. And in this case, there's something that we did that would do differently from other software and players. So we kind of purposely take the data visualization out from the functionalities from those batch processings, just because we found just to visualize the data or structuring the data will be very time consuming in some cases, because a lot of the data structuring or visualization will be the data will be pre-processed or loaded and pre-processed, structured for other analysis or processing that users don't necessarily need. And so we basically put everything in command prompt and just let it go through. And the EasyPC, again, is a data management tools. So we assume users have at least a very basic idea how they want to tackle the data, have a basic understanding of how those data is stored and so on. And unfortunately, there's not a single solution or a magic button to solve all your problems. So that's why we kind of take the approach that we develop a lot of small tool that can tackle a small problem, and then we can stack them up and we can put them together and custom the workflow. So that flexibility to us is very important, and we like in our research and projects, and we believe other users might need this capacity as well, because if you are fixed into a certain workflow, a pipeline, and that can take off a lot of flexibilities, and it's really hard to deal with exceptions. And the reality is that you have exceptions all the time. And also we found, between all the different data vendors, manufacturers, software, there are data issues, like in different ways. So sometimes people don't necessarily follow the specification of a data format, and sometimes they make some tweaks to the data or take shortcuts, and that really kind of break the compatibility of the data between different software packages in a lot of cases. And I call it a silent killer, because it's one thing that you found there are some data issues, for the first couple steps in your workflow, and it's another thing that you found that after the data is processed down very deep in the pipeline. So that means a lot of time for troubleshooting and figure out where the issues are, and also kind of try to sometimes it can cause like some blunders in the data products. So here is a few functions that I want to highlight, or a few considerations, like units of the data, whether it's meter, international field, US survey field, the map projection, the datum, and also the available fields. Sometimes, like you get the last file, you get an E57 file, you just want to know what's available in there. And sometimes the scanner has the multiple returns, and sometimes they are pre-classified, or they might write something into the source ID to identify different flight lines or passes or scans. And there's also other flags available in the last format, for example. For the RGB color, sometimes it ranges from 0 to 1, sometimes it ranges from 0 to 255 or 0 to 65535. So it can be all over the place, and that can break the compatibility of the data between different software packages and analysis very quickly. And so we develop tools. So here on the right, I'm just showing a quick example of one of the tools, just to kind of show last info. So you drag and drop the last file, LAS, LAZ files to the program, and it will just give you all the information about the fields, about the header, about all the basic information about this file. So in here, you can see it for each field, have the minimum, median, maximum, give you the range, calculated average and standard deviation. So just really, really basic stuff. You can check the data very quickly. So for example, here I'm looking at this data. I just learned right away, this data contained a classification field, and they are all populated as 40 for whatever reasons, right? So that's something that you want to make sure before you push that down to the pipeline, because this can be considered as a pre-classified point cloud data. So which can be a good or a bad thing, like down the lines. So here's just a kind of plain list of tools that are available for in EasyPC package. So we're coping with the E57 files, the LAS, LAZ files in EasyLAS, and handling the map projection in EasyProj package. And there's also a small package called EasyUtility. So I'm not going to read like every single one of those, but just so you know, we build all of those functions with a purpose. Like a lot of this is, we developed these tools. A lot of this comes from our project, our applications. We actually need this function to achieve certain goals. For example, here I have the Y up and Z up conversion, because the iPhone LiDAR data exported from those apps, by default, they're Y up coordinates, and we need to kind of transfer those to Z up to compare with other data sets and make sense of it, things like that. So the next tool, next collection of the tools is called the EasyVox. So this is like a kind of, if you think about the workflow, it's kind of push once you kind of finish the data management, and then now you're ready to process the data. And this allows a lot of pre-processing of the data. And so here's a few examples. So we have the 3D data tiling. And just to highlight, so the 3D data tiling that we implemented, you will have the option to add overlap area between tiles so that you can minimize the artifacts in the data analysis and processing, so that you don't need to deal with those stitching lines or artifacts between tiles after the advanced processing or analysis. Have the downsampling, the noise filtering. So down here I have two examples showing showcase the noise filtering. So one is on the building features on the wall, and you can see how you can adaptively remove the noise. And on the right, so this is actually a this is at a trench, and you can see those stakes on the ground, and they're removed by the noise filtering in this case. And there's also other noise removed from the point cloud data. So overall, you just can smooth the data a little bit. So this doesn't go through any ground filtering or other steps yet. So you just purely just noise filtering from there. So we have multiple filters built in just to make it more versatile to different scenario. Proximity filter is just to kind of, if you have a data processed already and then you have a different data collected later, and then if you don't want to kind of run through all the same processing again, and then the proximity filter will give you a good initial guess of how the data should be processed. For example, if you have the ground surface, then you just can find the points closer to the reference data sets, and then that can give you a pretty good results to start with. We also have the cloud-to-cloud distance, kind of to track the changes, the 3D polyline cropping, and the 2.5D modeling to get the grid or DEM with the gap filling and the some interpolation inbuilt in there. And it's also worth noting, again, all of this run in command prompt. You can do drag and drop. You can write command line. You can stack them up together to run batch processing. And they are very efficient, and they're all kind of running on the point cloud basis. So you give it a point cloud data, and it will give you a point cloud data back. But the difference is it's processed at that point. And here is an example showing the EasyVox workflow, like how you can run multiple tools to get all together, like in a pipeline, meaningful pipeline to achieve some certain results. So here I started off with the data tiling. So to break up very large data sets into those 3D grid, 3D cubes, or 3D tiles with overlaps, and then I'm going to downsample each tile. So from there, after the tiling, can process each tile in parallel or individually, and then I can downsample the data, apply the noise filtering, crop all the files down to the area of interest, remove those overlapping points that we added, and merge them all together. So now you ended up with one file, and then you generate the a 2.5D grid or models with hole filling, and then you do some comparison between different epochs or data sources to run QKC or any applications. And within that, you can also insert, for example, a ground filtering, a Volsmog ground filtering in the middle, like before you generate this model. You can also add EasyFit after that. They are all applicable. They are all compatible with each other. On the right, I'm just going to showing one example of the hole filling, and I believe Mike has a different approach for that interpolation for Rainbow package, and that's kind of the whole point of this. We have a lot of cases we have multiple tools achieving the same goals, but with like different emphasis and different strategies, so that we can tackle different scenario. And they're all from our practice, our research project experience, and we are the first users of our own tool. So with that, I'm gonna pass it back to Mike, or if there's any questions, I'm happy to answer.
I think you're
All
muted.
right. Yeah. I'm on 3 screens, so it's one of the things, the entire market, well, 2 things. The entire market seems to be concentrated on handheld data, right? Every big manufacturer out there is pushing some kind of handheld device, right? With your noise filtering, is there, I know that if I take it into software that's not meant necessarily for a handheld device, and I run the noise filter, it erases almost all of my data. Are you guys, how does yours work with that? And then I got a second one, just to tackle them both. It seems like most of the major manufacturers have also forgotten about the next generation of geomatic specialists. I know you guys haven't, right? But do you guys have a education software to help other geomatics programs out? Because the big dogs, they will charge you an arm and a leg even if you are another college, right?
Yeah.
So those are the 2 that came to mind.
All right, Ezra, do you want to take number 1? I'll take number 2.
All right, sounds fair. So for number 1, so the data that I showed, so so it's gonna be adaptive to the surface itself for the noise filtering. So you can adjust the parameter to make it adaptive to the data quality and the surface roughness. So because they, like we actually tested on the handheld or the mobile, the handheld scanner on one of those. So it worked really, really well. It's just a kind of a balance between how much absolute noise that you want to filter out, like how much noise from the sensor itself and how much noise from the surface. So it's like all the factors going in, and then so the good news is, as Mike mentioned this, so I just kind of want to reiterate. So most if not all the parameters that we have in those programs, in those tools, have physical meanings. So it's not just an alpha, beta, and then you need to give a number from -2 to positive, like 1,024. So everything has a physical meaning. So you can, if you know your data, you know what you're doing, and then you'll be able to, populate those parameters with a really, really good starting point. Plus everything we have those default values. So that's kind of one thing. And another thing, for the handheld data, so, one way that we can handle that is kind of getting back to the easy PC toolbox. We can divide the data by blocks or filter or split the data by fields. For example, if we split the data based on the time series, based on the timestamps, and that way we can, have a good local accuracy at least, and then deal with the drifting problem later. And then, like it just means in that EasyVox workflow that I showed before that, you're going to run a EasyLast split function to split the data or to divide the data based on the timestamps to achieve a better, smoother local data quality, and then and figure out those drifting and other things later. So maybe Mike, you might tackle number 2.
Yeah, definitely is, our day job, right? We work for Oregon State University and have been thrilled to kind of just see an explosion of our geomatics program here. And so, the software tools, especially the ones we develop at OSU, we make available to students in our classes. And so, like, for example, the rockfall analysis software and our VOSMOG ground filtering, been using in our laser scanning and terrain modeling courses for several years now. And, part it's been beneficial as we were developing the tools for research, because there's a way to break it, a student's going to find it, right? So they, always help us kind of identify issues. Our students come from all sorts of different backgrounds. And so, there's things that they try in the software that, I would have never even imagined thinking about doing, and it helps us kind of figure out solutions with it. So we do have educational discounts that we do to kind of help out programs purchase the software. We try to keep the price point low. And we do work with several students. For example, our rockfall software, there's a student in Norway that's doing a research project for their thesis, looking at rock slopes, doing analysis. And so there's a few students there that we've set up with the Rambo software to kind of help them with their research, so that they can, do the data processing and then feed it into their products there. So we're definitely very keen to work in and train that next generation of professionals, because, especially, I'm sure all of you in your companies, it's hard to find people that have, that kind of LiDAR experience and expertise. And when you do find them, they get jobs, a lot of offers at a lot of different places. And so it can sometimes be hard to keep people with that. So we're trying to build up more and more of those capabilities in different ways. Other questions?
It's funny when we touch on that. It's one of the things that I don't think like a lot of software developers think about reaching out, because so many people are getting into this industry. If you're teaching students how to use the software, when they go somewhere and try to implement it, they're going to go to the software that they know, right?
Yeah.
So I can see it being really helpful as far as selling software or teaching students on it,
Yeah, and I'd say, like OSU, we've got a partnership with Leica Geosystems, as they've been very generous to us in using their software. So we're able to use that in courses, and that's the software that students know when they graduate, right? So there's an incentive to the developers and the companies there to do that.
And also, in a very doctor moment, Karina who's on the now is
Hello.
is a peer of yours. She teaches at the Southern Alberta Institute of Technology. They're geomatics right now.
Yeah. Yeah, we've struggled with trying to get software for the laser scanning, and I teach the terrain modeling and laser scanning course, and yeah, it's been a challenge because it's just so costly. So
Yeah.
so it's good to hear that you have some educational discounts, and so I might be I will be following up with you about that.
Yeah, follow out because we know how much of a struggle it is, and that kind of
Mhm.
you've got the funding one year and permission to do it, the next year you don't. Now do you have to
Yeah.
change your whole curriculum, and you don't want to be in that boat. So
Yeah,
we
exactly.
we'd be happy to talk with you. And yeah, we were just up there at SAGES, the Surveying Geomatics Educators Society conference last July.
Well then you must have seen me.
Yeah, like we look familiar, so I think we met.
We must have met for sure.
And speaking of reaching out, I'm sure you guys are going to show this later on, but I just want to make sure that you guys have a slide or something with your guys' contact info if people want to make purchases or talk to you more about your guys' products.
Yeah. So our website's easydatamd.com.
Oh, I missed it.
Oh,
sorry. Yeah, down there at the bottom. Okay, perfect.
Yep, down there at the bottom, easydata.com, and I can put that in the chat, or you can contact us at sales at easydatamd.com, and reach us through that.
Perfect. And I didn't mean to hijack you. If you guys have more, feel free.
Yeah. I was gonna show maybe our last one was the rock flow analysis software, which is one we use in class, but I do want to do a time check because we are hitting at 5 o'clock there, so I didn't want to.
Yeah, I mean, this is
boundary.
supposed to be a very relaxed thing. It's the hour thing is more my boundary than anything else. It's not a big deal. We can keep on going if everybody wants to. We can take a consensus. It's a group. It's super relaxed group thing. Everybody want to keep going?
It is quite informal.
Yeah.
Yeah, keep
right.
going.
Keep going.
I'll jump when I'm ready to jump. I'm sure we all will.
All right. I'll go quick because when you tell a professor to keep going, it might be hours. So I'll just do like a quick couple-minute overview to Rambo, but definitely appreciate your interest, but don't want to keep you here all night. So I'll just kind of skip through. We have some slides with it, but this is our rockfall analysis software we've used on a lot of different projects for doing change detection analysis and evaluating different types of geomorphological features. So getting information on slope, roughness, curvature, and other things. And so really the idea behind this software was to streamline data products because we were sampling LiDAR data from a lot of different sites and we needed to come up with our metrics very quickly. So we streamlined the process from when you collect the data. Initially, you crop it down to the area of interest. We designed a custom ground filter to work on extracting vegetation on rock slopes. Most ground filters out there are looking more in the traditional XY plane, looking down at the ground. And as a result, it will filter out the whole rock slope with it. So it's kind of a challenging problem. Keep the rocks in there and the complexity of that, but get rid of the vegetation. Then from there, moving on to the modeling, the hole filling. And so what looks like somebody poured a bunch of paint on the cliff, those are the different holes filled in the rockfall surface. So we have an adaptive thin plate spline algorithm that kind of goes through and keeps the curvature of the surface as it fills in the holes in those different areas. And then from there, doing the batch change detection. So looks like shooting up the cliff with a paintball gun, which I do have a side story on that. I won't get into it right now to keep you with that, but each one of these different colors represent a different rockfall cluster between the different change epochs. And so once we have that information, we can now compute the volume of every single one of these and then use that to come up with these different risk curves. And so just kind of showing the process here, we have our change detection results, differences between the surfaces. Then we can look at failure clusters. And so we do basically the clustering approach, which looks like the paintball gun shooting up the cliff. So each of the different rockfall clusters that we detect there. So here's just kind of a close-up of this particular site with the different events. And then from that, we can turn it into tabular information so we can get a volume on each one and create what are called magnitude frequency curves. And so the idea behind these is the larger volume, or basically you have rockfalls of different sizes, and larger rockfalls come down less frequently compared to the smaller rockfalls that are more frequent. And so by plotting it in this way, we can create these curves that give us an idea of the relative risk of each site. because the farther a curve plots to the right here, that indicates there's higher risk because it means stuff's coming down more frequently. Likewise, if it plots down to the left, it means stuff isn't as frequent between the sites, and you can kind of use it to prioritize between the different sites. We also have a specific classification algorithm built in there called the Rockfall Activity Index. And so what this does is it searches the cliff, looks for surface slope and roughness and across different spatial scales, and starts classifying different features on the cliff. And so this is, for those of you who've been out in Oregon in the Coast Range, it's what we call the Tyee Formation. It's all over the place there. We have these big sandstone layers on top of these siltstone layers that erode very quickly. And so the sandstone layers basically break off as the siltstone underneath erodes. And so the algorithm goes through and classifies all those overhangs. So you can see that interbedding with all the red lines through there. It classifies the talus or the loose material down at the bottom, and then the intact rock and this green material. And then there's some intermediate classes, but I won't get into those today. But it gives you kind of a quick way to identify where those precarious overhangs and features on the cliff where you're expecting failures to happen. So this is the kind of the main GUI and interface to the software. So you come in and kind of select, what type of analysis are you doing? Are you taking, say, airborne LiDAR data and you want to generate models from it? Or are you doing rockfall data from different slopes? Do you want to do change detection? And so you kind of choose your options here, and it basically sets the parameters for the software to use. And so the right kind of gives those options, and it has kind of default text files that have the parameters stored. So you can kind of just cycle through those depending on what you want. And then on each of the pages where you need to set maybe more specific parameters for hole filling, depending on the size and area that you want to do it in, there's a help menu built in context. So at the bottom of the screen, you have, here's the help menu. It goes through, shows what the algorithm does. It gives you a table to say these are default parameters and the typical range you want to be in. And then at the end, for those of that are brave enough to scroll on, it gets into the theory of here's the algorithm that it's using for hole filling and the equations and how it works. So we try to build that into the software. So this is just kind of an example of some of the things in the interface that I'll show you. So here's an example of the change detection analysis menu, that you can adjust with it. Whoops, I just clicked ahead too far there. Sorry about that. So for example, the change analysis and things that you notice that are grayed out, they're grayed out because you didn't set the setting to enable those. And so that way you don't have to worry about those parameters. But it outputs different tools for looking at the data in Cloud Compare, as well as models that you can take into ArcGIS software. This is one of the landslides on the coast that we've been studying. So it creates grid files that you can take into GIS right away. For the files that we view in Cloud Compare that it creates, it stores all these parameters like slope, roughness, curvature as extra bytes. So you can easily transfer them into these different software packages that have the capability to read that. It's as part of the last specification. So Cloud Compare is an open source viewer that we use a lot of it in there. And so you can toggle on the different layers. So in this case, we're looking at the slope of the surface, and we can adjust the coloring inside Cloud Compare to look at those results. And so every point's tagged with all these different parameters. Here's just toggling onto the change detection layer with it, looking at the scale with it. And then here's kind of looking at the rockfall clusters. And so, while it outputs the point cloud data, it also is outputting tabular data for those that want to really dig into it and get the metrics for the site. And so, whoops, keep messing that up in there, sorry. And so there's all sorts of data that you can export as and review to basically create your different curves or analysis to compare different sites and look at those differences between the different surfaces that get output with it. And so this is just an example of applying some of the software to some rock slopes in Alaska and looking at kind of where those hot spots are on the cliff, where the erosion's been happening more frequently, and where some of the more challenges and precarious areas of the rock slope are. And so this last one here is just kind of showing a hotspot map. And so the software is set up to batch process. So if you have 20 different epochs of LiDAR data that you've collected at a site, as long as they're named in order, so they sort alphabetically within that, the software will then go through and match those up and perform change detection on time. And so you can look at localized areas and see how often does this particular pixel fail across those epochs. Did it fail, 5 out of the 20 epochs, or did it fail 10 out of the 20 epochs? And then it also looks at its neighbors and how often are rocks coming down in the vicinity of this particular area. So you can kind of create these really cool hotspot maps. So this is one of our sites up in Alaska, and these areas in red are the areas that are more active in terms of rockfall. And then we've been partnering with a company called Sensive, who then can install tilt sensors. And so kind of the idea is use the Rambo software to identify these areas. And then once you have them identified, then now you've got the spots that you can put sensors and kind of do the monitoring, since those are the more precarious areas in there. And so that was kind of fast, but kind of one of the tools, outputs a lot of different products for viewing both meshes in Cloud Compare or other types of software as an OBJ file, but also exports your elevation models for ArcGIS. But no, we're kind of putting some of you to sleep here, so I figure I'll pause.
That is actually a very astute observation. So I'm going to ask a question that Karina asked at one of our first Lido lounges. Is there anything in your software that would show, say, a rock trapped between two other faces?
So like getting the discontinuity joint sets, is that?
Yeah, or like the volume of the mass that is trapped between those two. And she can ask you this offline later on, but she's working on a PhD that is kind of out of the box for geomatics, but she wants to apply it to a larger scale. And so if that's something that a tool that you guys are familiar with, that might be.
So I'd say yes and no. It depends on the complexity and shape of the rock that you're looking at. So we're not doing like a full 3D solid volume in terms of that. And so what we're computing is kind of that difference between epochs, but doing it within a best fit plane kind of scenario there. So it sounds like what you're looking for is something probably a little bit more complex than that. But
well, actually, it's really quite simple.
Okay.
I have two very flat planes, and I have a complex shape in between. And I use lasers, so I used the BLK 360, and so I have the shape in between, but I need to get the volume that's in between these two plates. And so I can tell you where the plates are, and I can tell you like the shape of it, but to get the volume on the inside has been a challenge.
Yeah.
And the complexity of the shape really is that it's attached to a woman, and I still haven't figured those things out. So
yeah, it's for breast cancer research. So
we might have to delete that one for the recording there. Yeah, no, so we don't necessarily have it set where you can input the planes that way. We do have it set so you can input a plane as the reference for it. So, for example, GNS Science in New Zealand was working on using it to process some data, and they wanted to predefine their planes rather than having the automated one. So, but that would be fairly straightforward with the tools and the software to add a function that would do that. That would basically take the two planes, compute the volume relative to one plane, what's above, what's below of the surface, and output that out. And I think, Ezra, you've developed a tool similar to that for another project that we were working on. So short answer is, yeah, I don't think it would take us too long to put something together to do that.
Yeah. I mean, the most, I think like just top of my head, the one way to tackle that is whatever complex shape, you divide that by half, and then you start calculating the free space rather than the volume of the object itself. So basically you draw a perimeter of that and then intersect with two planes. And then you do a volume calculation, use Rambo or other software, going to the top plane and then doing to the bottom plane. And then you kind of divide things into half and then calculate the volume, in different sections. It doesn't need to be two. You can keep dividing that. So that way, I think you can get the volume more reliable and more straightforward than actually model the object itself. So
that's very funny. It's a much larger scale, but that is exactly how I find the volume of a concrete deck. When there's complex beams and steps and stuff, I start taking squares and dividing them into sections, to cut them in half. That's very, very similar.
Yeah, I've been using FEM to try to calculate the volume, and that's been good as long as I have the planes set. So I
Yeah.
was just curious
Yeah.
to see what you guys had. So thank you.
Nice. Well, thank you guys for sharing that. It just well, we've had a few people drop off, but they have your contact info. So if they want to reach out, they definitely can. Hopefully, they'll give you some feedback too.
I
So
forgot to put
I had
the
a
website in the
I had a
address.
question.
Yeah.
Go ahead if you wanted to show something.
No, I think we'll call it good for showing unless you want us to show
Okay.
something specific. But yeah, ask your question. We want to make sure you have time for that.
Yes. So I was going to ask about the the workflows and the modules and all of that. So, is Rambo kind of an exemplar of what your software would look like in a workflow package? If somebody says I want modules, X, Y, and Z, do you basically wrap it in a UI similar to that for them? Is it, kind of a roll your own where I think it was either Mac or Gabe said something about, it kind of reminds you of like video converter software. So
Yeah.
is it, individual modules where you plug something in, get it out, go to the next thing, are you scripting it yourself with Python? I guess I'm just trying to understand the interplay between the different modules and kind of what that looks like, I guess, for an end user.
Yeah, that's a great question. And so can answer it. Depends on what makes sense for the person that we work with, right? We want to make sure that it's something they're comfortable with maintaining in that regard. But we basically what we can do is we package it. Rambo's kind of a bigger package with a lot of different options packed into it. But it could kind of be something like that where our tools behind the scenes we write them as basically command line tools, and we have settings as text files, so it makes it very easy to swap things in and out and change it without having to load up the software, load in all the point cloud data. You can kind of manage all that. And then we can basically package it up as a simple GUI that you just basically can say, here's the parameters that I change, that I need to change. These are the 5 parameters, and the rest of the parameters, the default ones, work great. I don't want to even think about them and look at them, right? And so those get built into the GUI, and then you have your run button and maybe a console that prints things out at the bottom of the screen so you can monitor it as it goes. So that's kind of typically how we've designed a lot of our software to work, and how we design our GUIs kind of for our customers. We're in the process right now of revamping some of the GUIs. We have a partner that we're working with that specializes in GUI design to kind of help make those maybe a little flashier, if nothing else. But more to kind of add in more air checking and other kind of capabilities with that there.
And with the error checking, the kind of QA/QC sort of workflows are something you're building more of as well, or that's kind of up to the end user to figure out what works best for them to kind of spot check and do those sorts of things.
Yeah, so kind of a couple things. So like, for example, in Rambo, if I want to do change detection, then I need to analyze all the data sets in the same way, right? So there's air checking built into Rambo. If somebody says, process all of these in different best fit planes, the best fit plane of each data set, then your change detection is not going to work. And so it automatically says, you want change detection, now these are locked in. But somebody else may say, hey, I want to run Rambo, and I just want to batch process these 10 data sets. They're all completely different, but I just want to do it in one run, right? And so they can customize the settings to do that. So it has, kind of air checking to kind of make sure that those issues don't come up there.
So just to add to that, I think, like one way we are thinking about this is, depending on how much data you're dealing with, how frequent you're going to use this workflow. Like if it's your day-to-day routine workflow, then yeah, it might be worth for us kind of developing a GUI for you. But if it's just a special case, just a one project, for example, right? And you kind of have a GUI locked in your workflow, and then that just doesn't do you any good in our opinion, just like all the big dogs, right? Like they have all the tools packaged in one suite, and you need to pay a lot of money for a lot of tools that you don't necessarily use every day. And plus the training, from 1 day of training to a week, because all the functions that you're not going to need. So
Hey,
right? So
some of us make decent money off that training, so let's not.
Yeah. So no, I mean it's just kind of we are positioning ourselves between the existing workflow that you have, so that we are not replacing anything. We're just make your life easier. So that's all it is.
Yeah, most of our tools are these fill the gaps between the different software packages we were using in research, right? So we don't want to reinvent something. And then, so it's either going to be something that does it a whole lot faster because the current tool is too slow for us, or it's painful trying to get the data in and do these different pre-processing steps, and we want to minimize that kind of grunt work, so to speak.
Well, what I find really appealing about your guys' situation is A, the growth potential of turning into something that can disrupt the market. B, the fact that and I know you can't disclose it, but I'll throw it out there. The fact that some of it does go to a good program,
Yeah, we can, to be clear, we can disclose that OSU was part of it, right? It's just they like the amount.
and I was never interested in the amount. It's just the fact that some of it does. Part of the reason why I chose Leica when I did as a customer was because of not necessarily a lot of their money went back to research. So I knew that buying into their products was going to get me another product that was better down the road. So that was a somewhat selfish reason. And real quick before we finish up, you guys shared with me, and this isn't your guys' software, but you guys shared with me a viewer, and I didn't have a pen to write it down, but it looked like a really good viewer. And that's been a thing in Lido's Lounge for a long time, is how do we share data? Do you guys remember the name of that?
Yes, Potri.
What is it?
Send you the link.
Yeah.
So this tool, and if you want, we can come back or have maybe grad students, so you don't have to listen to us talk.
Well, I would love to have you guys come back.
Do a demo of this. So in our laser scanning, this is part of the first assignment, is for people to create a point cloud viewer. We kind of talk about LiDAR visualization, have them do some screenshots and animations, and then tell them they need to create a web page. And most people are like, wait, you're asking me to do all this on the first assignment? It's like, yeah, you just run this converter and a command prompt, and then you copy these to your network space on campus, right? And now you've got a viewer you can share data. It's really that easy. It's a really powerful viewer system. So Potri converter. They have basically the converter that you can download. They got lots of samples to show. You can bring in CAD files. You can bring in you can bring in ArcGIS shape files into it, annotations. There's ways to add photographs, but again, some of those things get into more kind of HTML coding that you would need to do to kind of add in that complexity. But the basic viewer is just a really simple converter script that you run and put the files in there. So it's
the fact that you have students do it means it's not expensive to run it, right?
No, it processes.
And that's where everybody wants to be, is we're spending so much money on software, which is a good thing.
Yeah.
We don't want to spend money to share what we're producing.
Yeah. This is open source. The developer, he wrote it for his master's thesis, and he basically at one point was going to commercialize it, but then he backed away from that. And so there's no charge for using it. He's got a lot of funding, from different companies and so on that have kind of donated to kind of help things go. And so he's kind of gone that route. So
sweet. So before we get up, I know a lot of people dropped off, but since this is being broadcasted, I'm going to go ahead and throw out for the next meeting. I kind of want to talk about something that's near and dear to more of the construction guys, or I guess the industry guys, is how do you quantify change orders that don't happen? So say we start laser scanning and we fix problems before they become problems. How do we continue to justify spending money on software and equipment when accidents aren't happening on construction sites and such like that? So just to give a little bit of heads up for some of the topics for the next one. And if anybody else wants to, have other topics, of course, it's always an open forum. But I'd love to have you guys come back, and sit in.
Yeah, definitely. We'd love to participate. That sounds like an awesome topic. And yeah, it's something we always kind of challenge, trying to find good information on how much you spend on that initial site survey and how much it saves you in the long run. And there's not a lot of good data out there.
And it happens with survey too. We initially get a lot of instruments and stuff thrown at us right away because we have all these problems, We fix all these problems, and then the penny pinchers start taking that money away because they're like, oh, there's no problems, you know.
Yeah.
So, just something to think about. Thank you guys for coming. Is there anything else anybody wants to add? No.
Yeah, thank you all for sticking it out with us and letting us talk. But happy to talk in more detail about anything. If you have questions, feel free to reach out. And look forward to seeing
Thank you
them
so
for
much.
these.
Yeah.
Awesome.
Yeah, thanks.
All right. Thanks,
Thanks,
Aaron.
guys.
Thanks.
Good touch, Rita.
Okay.
We'll see you.
See ya. Bye.